It is my great honor to take a moment to just introduce our speaker today, who is Marian Small. For those of you who don't know Marian, she is an internationally renowned speaker and author. She's authored more than 100 books, including and resources, including all of the MathUP products, and we are so delighted to have her here with us today. And I think she's going to be sharing an insight into sort of some of the thinking behind some of our newer resources. So delighted to have you, Marian. I have the chance, I've seen so much of Marian in the last little while, but I always learn something new. So I can't wait. And without any further delay, welcome, Marian, and take it away.
Okie doke. So let me share my screen. Give me 1 second. I said, please share. We hope it listens to me. Looks like it might be. Just give me 1 second. Okay, so here we go. Um, Lots of you are familiar with MathUP Classroom. It's a resource that I wrote. It's been out for maybe 7 or so years now. And it is used across the country by lots of people and provides a great deal of materials for teachers to use. But there were some issues that have come up that led us to add to that. And so today is really to talk about that. So, first, we'll talk about the importance of consistency in math instruction. It's really helpful if instruction matches assessment, if instruction in grade 1 matches instruction in grade 2, in grade 3, in grade 4, so students have a consistent picture of what math is all about, so parents have a consistent picture of what math is all about for their children, and to make it easier for teachers as well. We're going to talk specifically in terms of the new resources about the importance of collecting but using diagnostic information. So we don't want to just give a little test and put it in our drawer. We want to use the information we collect. We want to collect the right information. So we'll be talking a little bit about that. We'll also be talking about the requests from teachers for more practice activities for MathUP, but they wanted activities that are consistent and coherent with instruction. Again, so the kids aren't mystified about how math really works. So we'll talk about that. Ways to revisit lessons that kids might have gotten a little confused on things, again, with this consistent sort of messaging. And I will give Michelle the opportunity to share with you ways to create even more practice on your own using our tools. So let's get started. When kids have math 1 year, where the teacher has one approach to math, and then the next year the teacher has a very, very different approach to math, and then the next year it might change or it might go back and forth. It's tough on kids because they just don't know. They want security and they're not sure, like, should I do this or should I raise my hand? Because maybe she doesn't want me to say that, and it's hard on them. It's hard on parents. Like I've been to parent nights where they'll say to me, well, how come the teacher last year said they had to do this, but the teacher this year says this? So we don't want that. It's hard on administration in a school because they have to deal with those parents who ask all those questions. And it's just hard on the system in general. So, one of the things we've been trying to do in MathUP is develop coherence all the way from K through grade 9, which is the highest grade level we've written for, that lessons are structured the same way, activities are structured the same way. There's the same philosophy of what math is all about. And when we create new resources, we want them to blend into that same framework. So right now in MathUp Classroom, for every single topic in every single grade, there is something called a diagnostic task for that particular topic. And it gives you some ideas about what we're looking at from previous work and some suggestions about what you might need to go back to for some students. But then there was a request for a little bit more. So what we've done is created something that we're calling Numeracy Readiness Checklists. There's a lot of talk these days about screeners. This is not a screener, it's a diagnostic. So, what that really means is yes, it's going to ask questions. Yes, you can collect data, but it's also going to tell you what to do when you see that data. So, that makes it what we call a diagnostic rather than a screener. We have created numeracy readiness checklists that are particular to the curriculum in Ontario, the curriculum in Alberta, the curriculum in the rest of the country. Now, there are variations in BC and other provinces, but they're very close. So the screeners make sure that they adjust for your province and what your kids need. There are two kinds of readiness checklists. So let me talk to you about both kinds. One of them is called a snapshot. So what it does is I thought about what kids, for example, going into grade 3, should bring from grade 2. Like, what are the most important things I want to know about what they're bringing from grade 2? It may be from a bunch of topics. It's all focused on number in K to 6. There is a bit of algebra in 7 to 9, but it's all focused on number in K to 6. What are the most important things I can give? But I don't want a million questions because that skews the data. Students see a million questions and they get scared and they don't actually show you their best. So we've picked either 12, 10, that sort of number of questions that we think would give you a good feel for what your student is bringing in. So it doesn't overwhelm the kid, you get reliable data. The other thing is that just like we do for everything else in MathUP, we ensure we look at both skills and concepts. Many of the screeners that are around only look at skills. You're going to see examples, so you're going to see the concepts as well, because we need to know if they are there as well. Now, what deeper dives are sets of more questions. There's sets of questions that you can give throughout the year prior to instruction on a topic. So let's say I was in grade 4. There might be a set of questions, maybe 6, 7, 8 questions about fractions. There'd be a different set of 6, 7, 8 questions about addition, subtraction. There'd be a different 6, 7, 8 questions about multiplication. So you would use those little complements of questions before you embarked on a particular topic to see if kids are ready, or do you need to do some activities to get them ready? So that's the difference between snapshot and deeper dive. So snapshot is like 10 or 12 questions. If you look at all the deeper dive questions, it might be more like 60 or something like that in total. And as I said, they include both skills and concepts. For every single question, and I'm going to show you some examples, there are notes to you, the teacher, to help you make sure students really understand what you are asking them. Because too often students take tests that are external to you and they don't understand the question. And so they're getting it wrong, but they really knew the idea. So we're helping you find ways to make questions clearer to students. We're suggesting to you what materials kids should have available. But what I think is really is important is we're telling you why we're asking that question in the first place. What do we want to know about kids when we ask that question? And the teachers who've already used this have been very happy with seeing the intentions. We give you for each question a scoring tool with a recording tool to help you kind of look overall at where kids doing well, where are they not doing as well. And the scoring is, of course, related to the intention of the question. So if kids make a mistake that has nothing to do with the intention, we're not going to worry about it. We're going to look at the intention of the question and help you score based on that. But the best part is that for each question, we are suggesting to you support. So we're giving you activities to help kids who struggled with those questions. Some of them link back to MathUP classroom lessons from previous grades or from previous topics. But other activities are just brand new activities that you can use to help kids who are struggling with something so that before you continue, you can fix it up so they're ready for the new piece. And we're also providing what we're calling a check-in question, so you can compare their performance on on the original numeracy readiness check, but also after you gave them the support. Like, did it work? So are they doing better now that you've done support? So we'll give you some insight into, is this working and how is it working for my students? So here's just a few examples to give you a feel for it. And I'm not showing you a whole grade for anything. I'm just showing you pieces. So here's an example. This is for grade 2, and that means you're looking back at work from kindergarten and grade 1. And so you'll see there are questions like, what's the answer? 12 minus 4, 10 minus 3. Show me how much more 15 is than 7. Subtract 2 different ways so I can see if kids have ideas for different ways you can subtract. Notice that there are teacher notes there that I mentioned. Tell students they can do this, provide this, remind students of this. And there's also those intentions. So the first question is to see, do they know their facts? But the second question is, can they relate addition to subtraction? And the third question is, are students flexible? So we're seeing those various things. Here are a few more questions in the subtraction section. Evan says 14 minus 9 must be the same as 15 minus 10. How do you know he's right without even figuring out the answers? So you can see that's the very MathUP style, very conceptual, not just procedural. Or look at 5.5 to figure out 12 minus 6. Someone first did 10 minus 6. Like, what should they do next? And why did they do that in the first place? So you're seeing that mix of procedural and conceptual. Make up a story for 15 minus 7. And we've actually rewritten make up a story because kids are actually writing stories. So it will soon say, give us a situation where students would do 15 minus 7. And so you'll see the intentions. Um, in red, this is the scoring guide, and I'm not going to go through it, but you'll see that there are point levels, and in red, we give you sample answers that kids might give you. So there's a whole section with the question repeated for you with all the sample answers. At the end of that section, there is a summary to suggest for you what scores would make you happy, what scores would make you worried. So just to give you a feel for expectations. This is the tracking sheet that's going to allow you to enter. It's an Excel spreadsheet, and you'll be able to enter scores, and then you'll be able to kind of color code to see where are things good, where are things bad, because there will be different colors showing you good and bad. Um, and I wanted to show you a bit of a section about the targeted support. So this is to say, what will you do if students are struggling with question 5.1? So I'm suggesting if students can't model a subtraction, which is what question 5.1 is about, here's a bunch of stuff you can do. And here are some links back to MathUP lessons that could also help you. So there are MathUP links and there are other support activities in case you choose to use those instead. There is that written for each question. So every question gives the teacher support for what do you do if we have a problem for that student. Then I have recently written the check-in questions. So they're not pretty yet. So you're going to see sort of not pretty check-in questions. So it might say something like, we looked at one question that said show two different ways to do a particular subtraction. Here, I just picked different subtractions. Or instead of saying to figure out what I said before, I think it was 12 minus something. This time I said for 16 minus 9, she did 16 minus 10. Why would she do that? What would she do next? So they're very similar parallel questions to see if there was progress. I made sure that the point values were the same. So if you went from 0 to 2, then you'd see I really went up. If you went from 0 to 1, you see that. So the question points make it really easy to tell what your improvement was. I'm just going to show you a little bit of what a snapshot looks like, and I just randomly picked grade 4. So a snapshot question will be about a lot of different topics. It's the ones I chose as I thought maybe most critical in number. So in grade 4 snapshot, which looks at grade 3 material and earlier, you can see that question 1 is about place value. Does a kid understand that 304 is not only three hundreds, 0 tens, and 4 ones, but also 200s, 10 tens, and 4 ones, and a bunch of other things? There's comparison, again, place value. Question 3 is about, can you put numbers on a number line? Can you compare numbers? Question 4 is about fractions. Question 5 is also about fractions, but it's very conceptual. If that is a quarter, what does a whole look like? Question 5 is about addition. 6 is about addition. 7 is about addition. 8 is about subtraction. 9 and 10 are about subtraction. 11 is about multiplication. 12 is about multiplication. So there's 12 questions covering what I thought were the criticals from previous grade, just for the beginning of the year to give you a feel for your students. Again, it has all the kinds of supports I showed you for the grade 2 questions. And one thing that I didn't say here is, again, there's a summary that says, if I saw this score, I wouldn't be panicked. If I saw this score, I might worry a little more. Um, and then I'm just going to show you, just so you can see it's the same for all the grades. For grade 7, we're looking at grade 6 work. So here I'm looking at, this is the section on representing and comparing decimals. Notice that A is about hundredths and B is about thousandths, because we know some kids are okay with hundredths, not thousandths, and we want to see where these kids are. They're representing as well as identifying decimals. They're comparing decimals in 4.3. The intention is there. Is there a number between 42 hundredths and 43 hundredths? And a whole bunch of kids will say no. And we want to see if they know that that is not correct, that there is a number. So again, a mix of conceptual and procedural questions. Writing each decimal as a fraction is actually much more procedural. 0.26 is 26 hundredths, like that's what it means. Rounding is a skill as well, so you'll see all of the skills that your curriculum addresses. So I've taken these pieces from different provinces, so it might be not your province, so that don't panic if it looks funny to you. It could have been a different province. Again, you can see in the red, that's in the scoring guide, so we're giving you the answers. And again, we're giving you activities to do if students are struggling. In this case, with questions 4.1 and 4.2, this is what I recommend you do. But there is also a link back to a MathUP lesson that will also help you if you want to do that. So I'm just showing you pieces just to give you a feel for it. I don't expect you to read all of this. This question was, remember, I asked if there was anything between 42 hundredths and 43 hundredths. And so I'm suggesting to you, what are some activities you can do to help kids better understand that? So that's what the numeracy readiness checks are about. We have them for grades 1 through 9. Each grade has the snapshot. Each grade has different numbers depending on the grade level of deeper dive sections. In the very early grades, grade 1, grade 2, there are fewer sections than in the older grades where more content has been developed. As I mentioned, there is algebra in grades 7, 8, and 9. There's also ratio and proportion, percents, things like that in the higher grades. Now, the other product I want to talk to you about is something called MathUP Student, and it has to do with practice. And so I'm going to talk to you, I'm switching gears a bit and talking about practice. And one of the things when I wrote MathUP Classroom, I really believed there was sufficient practice in there for most students, but not every teacher agreed with me. And so there was a concern that they felt that some students needed more practice than was there. And they were going to various places to find this more practice, but often it wasn't consistent with the kind of instruction they were giving. So we wanted to provide practice that was more consistent with instruction so that it practiced both skills and concepts. So right now in MathUP Classroom, I believe there's lots of practice in the number talks, in the your turn questions, sometimes in the action task, but we created this new tool to have even more. So for grades 3 to 8, For every single topic in MathUP Classroom, there are usually 10 skill questions, most of which are auto-scorable. I'll show you what that means so you don't have to mark them. There are also 8 concept questions, and that might involve conceptual understanding, it might involve problem solving, it might involve communication, it might involve reasoning. And those are not auto-scorable because, in honesty, you have to hear what your kids have to say. So these ones are give you a window into your students' minds. The other ones are checking, did they get the skills that we hoped for? Now, in grades 1 and 2, originally didn't write check up the skill questions and concept questions because we had what we call supporting activity centers in grades 1 and 2. But I was asked to do some. And so what I've done is created some skill and concept questions. This is for each province. But they are what I call asset focused. So I'm giving the kid a little more input into how he or she shows me what he or she knows. So I'm going to show you some examples just to give you a feel for it. Here I'm using the every province except Ontario and Alberta version, the national version. But again, there are some BC in particular questions as well. So here is something you might see in grade 1. Choose a number to add to 4. Show me how you could count on to add your numbers. So what I meant by asset driven is I'm not saying you have to start at 7. I'm saying you pick a number and start. So maybe you want to start at 2 because you're more comfortable. Maybe you want to start at 7. You get to choose. And then the teacher, it can intervene. So maybe the kid picks 2 and you really think he could do better or she could do better. So you say, that's great. What happened if you started at 5? Or you could decide, leave it alone. It was fantastic that they started in 2 and did it right. So you'll see that there are those kinds of questions. Look at question 3. A triangle costs $2. A rectangle costs $3. Make a picture with triangles and rectangles and tell me how much it would cost. So they get to decide how many triangles and how many rectangles. Make 3 groups using the same number of counters in each group. Tell how many counters you used altogether. Here's a conceptual question in grade 1. Why do you count on to add? Make up a real life problem you could answer by figuring out 5 plus 2. Make up a real life problem you could answer by figuring out 2 plus 2 plus 2. So you just get the feel for they're more asset driven. Here's grade 6. These are what we call auto-scorable. And so what it means is the kids can put in their answer and the computer will score for it. And these are skill questions. So look at the first one. Which number is composite? That means not a prime number. Classify each number as prime or composite. Those kinds of questions. Write the prime factorization of a certain number. Which number is not a multiple of 9? Very straightforward skill questions. Excuse me. So those are the kinds of questions you would see. This is grade 6. The skill questions come with notes and a scoring guide. And so we tell you which lessons go with which questions. And this is when it's auto-scorable. The kid enters it in the computer, they click, and it will check their answer. Michelle may be showing you a little bit of that. The concept questions also come with notes and an answer key. So again, we're telling you which questions go with which lessons. So look at question 1. It doesn't say, is this a prime or not? It says, who's more likely to be a prime, 511 or 516? So does a kid know instantly 516 has no hope? And so it's going to be 511. So it's a different kind of question. Could a number with 5 as the ones digit be a prime? I want a kid to understand, usually not, but yeah, if it's 5. So those are more conceptual kind of questions. Explain why every multiple of 10 is also a multiple of 5. So what the kids are practicing is, because practice shouldn't be practice of only skills. It should be practice of skills. It should be practice of communication. It should be practice of reasoning. It should be practice of problem solving. So we're trying to practice all those things. Michelle is going to show you how we are using artificial intelligence, AI, to generate even more practice questions if you want them for some kids. Um, but it'll be in the same style, in the same framework that we're working on. It's not just open AI, it's kind of guardrails to make sure the questions, again, are consistent with what we want. The other thing that she'll be showing you in a few minutes is how we have virtual manipulatives embedded that are provided by Brainingcamp. And we can use those to for kids to work with those virtual manipulatives while, in fact, they are answering these questions. So I'll show you that in a minute after I show you one more thing. The last thing I'm going to show you is that when we went through to create this, we were thinking about something like the Khan Academy and how often, kids in grade 7 or 8 will sit there with their parents and go to Khan Academy to try to figure out something they didn't understand. Well, what we wanted is to do something that was a little better than Khan Academy, that was more clear for kids, help kids understand math more deeply. And so we picked a lesson in each topic that we thought might be the one that the most kids might struggle with. And what we did is we created a video to almost like reteach that topic, but it's a video they could watch at home with their parents, very visual, very clear, so that they understand the ideas. There are notes with the video, there's extension questions and so on, but it's something that would help them learn a little more. So let me hang on here. Where's my mouse going? My mouse doesn't want to go where it's supposed to go here. Hey, mouse. Okay, let's try it this way. Okay, Michelle, you might have to do this because my mouse is acting up. Woo. This is
Do
crazy.
you want me to just show a video,
Yeah,
Marian?
show a video. So I have grade 3 algebra lesson 1.
Okay, so I'll
Sorry
just
about that. I don't know what's going on here.
sometimes strange things happen. Okay, I'm going to.
So I should stop my sharing. Oh God, how am I going to do that? I can't even do that. Okay, something good happened. All right, I'm going to stop sharing. No. Um, all right, good. I got my thing back. All right, you go. Because crazy things just happened to me. So if you don't mind, just show us one video, and then you can take over.
Absolutely. Sorry, what grade and which
Grade 3, and we were looking at toot, 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 um, algebra lesson 1.
You have worked with equations before. Equations describe relationships between numbers. The equation 12 equals 4 plus 8 tells that 12 is made up of a 4 part and an 8 part. You have modeled equations in different ways, such as with a pan balance. In this example, 12 is balanced with 4 and 8. You can also model equations with a bar diagram. In this bar diagram, the top row shows the total of 12, and the bottom row shows the parts that make up the total, 4 and 8. The bar diagram shows 12 equals 4 plus 8, but it also shows 12 equals 8 plus 4. The diagram also shows that 4 is 12 minus 8, and that 8 is 12 minus 4. That's because the 12 bar is 4 longer than 8 and 8 longer than 4. To create a bar diagram, it helps to think about the equation you want to model. Let's model 6 plus 15 equals 21. You could start with a 6 bar, then create a 15 bar. 15 is greater than 2 6s, so the 15 bar should be longer than 2 6 bars. Because 21 equals 6 plus 15, the 21 bar will be the exact length of the 6 bar and the 15 bar combined. Now let's model the subtraction equation 25 minus 12 equals 13. Looking at the equation, you'll see that 25 is the total, and it is split into 12 and 13. 13 is just a little more than 12, so the 13 bar should be just a little longer than the 12. Then add the 25 bar to show the total of 12 and 13. Of course, you could always start with 25 first, then
Okay. Is there something else you'd like me to show, Marian?
There was another video, but it's like this is too crazy. So I apologize, everyone. I don't know what's happened to my computer. But I just wanted you to see. We'll take some questions afterwards, and I'm going to let Michelle show you some things as well. But I just wanted you to see that when you look at the videos, what I didn't do is have cute little avatars jumping around all over the place, showing kids a whole lot of stuff, because I want the math to be clear. I don't want to just like make them watch a video. So I feel like one of the things I want you to be thinking about is sometimes we distract them when we make it like too cutesy. What we're trying to do here is math has a lot of visual components. We want you to see those visual components so they make sense to you. Michelle, you take over now.
Good. Thanks, Marian. I guess I'll just ask if there are any questions at this point. We'd be happy to take them. And if not, what I'm going to do now is just share a few of the sort of add-ons. So Marian has really taken us through that important pedagogy piece. And so I'll just share, first of all, a brand new feature of MathUP Student. So if you have seen maybe this part before, you haven't seen this because this is just about to be launched. And what this is some opportunity to get support from AI. We are not really going to focus on the lesson plan because we feel that MathUP Classroom has such a rich foundation in lesson planning. But two areas that we know where educators can sometimes appreciate a little bit of extra support is to have extra practice and also support with differentiation. So I'll just start with the practice generator. These will be completely linked to the appropriate curriculum to your area. But for now, because we have people from different areas, I'm just going to put in a concept. So something like addition or multiplication or fractions. I can select my grade level. And then I can think about what kinds of questions I want to ask. I can have fill in the blanks or multiple choice. So if I'm trying to prepare students for that EQAO test and I would like to do a little bit of strategic test planning, I could choose multiple choice, but I'm probably more likely interested in some open-ended questions so that I can get them really thinking. And as you can see, I can be asking, and there's a lot of intentional choices being made here. Do I want skill and fluency? Do I want real-world problems? Do I want higher order thinking? And then this is where I can have some fun if I want. I can add a theme. So, I can make it all about hockey. We're in the hockey playoffs right now, or Taylor Swift if she's my favorite, something that, just might catch the students' interest. And at the same time, Marian was just showing us some work with addition. And so I might say, I'd like to see some questions that practice using number lines. So then I would just go ahead and get this practice. And it's going to give me some questions here. And then as I come down here, it's going to also give me that answer key and give me some good support. And if there are any additional, like if I need a, let's say I'm using base 10 material, or it's asking for something that would require like a chart, that will also be provided for me here. So not only is that practice all provided for me, I can also then save that to my library. So those of you who are familiar with MathUP Student know that you can collate and curate your own set of activities. Those can come from MathUP Student or MathUP Classroom, and now from the library. And I can go ahead and save that. And then this activity will now be here in my library, and it's ready for me to, if I want, I can go ahead and assign that to any of my students. So there it is, and all I would have to do is go through the process that I would for assigning any activity. And it will end up, and to say, and of course I can assign this to my whole class or just to an individual class, or sorry, an individual student. So this could be for differentiation. I want just a few students to receive this practice, and then I can go ahead and assign it. And now just those students will receive that particular set of questions. Or if I had wanted it to go to my whole class, I could have done that as well. So that's one piece of the AI. The second piece is the differentiation assistant. So again, everything will be matched up to the outcomes or expectations in your area. But for now, because we're dealing with lots of people from all over, let's choose something different. And this time I'm going to choose, let's say, grade 5. I have some options here, and this is again really helping us be a little bit intentional. It's very different than just like jumping onto ChatGPT and saying, give me 6 questions for fractions, right? I'm really thinking about how I want to differentiate this. Am I trying to have like an emerging or on level kind of differentiation? Am I trying to think about different ways to approach the questions? And so we're going to look at both of these. So let's just start with the difficulty. Again, I'm making some intentional choices here. I'm going to say this time I want this to be small group. I can, make the theme again if I want, or any other custom instructions. I can even ask down here that I want this in a different language. So I could say, please make all the questions in Finnish if I wish. So I can add that as an option. And then I would go ahead and generate the activities. And because I said that I wanted it to be differentiated according to level of difficulty, I'm going to actually get 3 different areas here. I'm going to have emerging ideas. So these are ideas for students, essentially parallel tasks, right? And I've, made it, in this case, it's going to be all about Taylor Swift, although that's, not necessary, but just modeling that is possible. And then you'll see then, so that would be the sort of emerging level. And you can see, as I mentioned a second ago, if I happen to need a tool, that tool will also be available to me. So it's just loading. Sorry, it's a little bit slow here. It's going to show us a place value chart, which I would then be able to use with my students. It's in its slot. There it is. So it's giving me that tool. And then I would also be able to equally find an activity that is for on level or students who might be reaching a little bit beyond. So that is if I want to do it by level of difficulty. Let's just swap things out now and change this to modality. And I'm going to get rid of Taylor here. And so modality is now going to give us like different ways to share this learning. So in some cases it might be that it's very visual, or perhaps it's a little bit gamified. So I can generate again, and it's going to come up with some neat ideas. And if I don't particularly love these ideas, so this time it's given me visual representations, collaborative work, and project-based learning. So I may have some students in my class that I know really benefit from the opportunity to do things in a visual kind of way. And so there's an example for that. And of course, like I can write in here, use decomposition, use number lines, use place value, like I can add whatever custom instructions I want. So that, we can show you a little bit more, but we definitely don't want to keep you here all day. But that gives you a little bit of a sense of the AI generator. It's what they call a walled garden. So what this means is that it's a little bit safer than just like being open to the whole internet. It doesn't learn from the internet, and the internet doesn't have access to it. So it's safer for students and for districts who are using it. And you can see once again, I can save that, and I can assign it through my library if I wanted. So that is the studio. And then I'm just going to come back here and show you one other feature. Doesn't matter what program I'm in, or sorry, what grade level I'm in. Marian just did a beautiful job of explaining the in-short videos and the autoscorables and the skill and concept practice. You can also find the digital games these are the same ones that we would find in MathUP Classroom, but they're here for us as well. Mine always defaults to French. I'm not sure, that must be some sort of feature that I have when I open it up in my settings. But and so the digital games are then available, so students would have these for regular practice at home, or I could assign a specific one. So that's a new-ish feature that we have. And then the last thing that I'd like to show you is the Brainingcamp virtual manipulatives. So I'm just going to once again go into any of these um, lessons, and I'm going to be able to find Brainingcamp. And there is actually an even bigger, better version of Brainingcamp called Brainingcamp Live, which we won't show you today, but we're super happy to send you some information on that if you're interested. But this will just sort of get us started and give us an idea of the kinds of things that are available to us. So you can see, all kinds of different manipulatives. I have color tiles. So for example, if I wanted to say, show me lots of different ways to build the number 8, similar to the kind of thing Marian was just showing us a second ago, this would be a way that I could demonstrate that. I also have the opportunity to grab things like 10 frames, and then I can take that tool, pop it up here, and it will automatically pop it into my 10 frame for me. If I come back here, I might want to look at, say, base 10 material, and let's say I want to be looking at whole numbers, although I could choose decimals if I wanted, and I just want to be looking at flats, and we want a place value board of some sort, and then I might want to say, please show me the number 143. So I'm just going to pop this one over here. And then I might say something like, okay, well, what happens if I do this? Is this still 143? So this is a very nice way, and you'll see these kinds of activities all through MathUP, helping students recognize. Like in the old days, we used to talk about place value, and I know, Marian, you'll remember these silly sheets where it was like, how many hundreds, how many tens, and how many ones, and the kids would just write 143 but they weren't necessarily thinking. So we want to make sure that we're recognizing that if we have 13 ones, that's still 143. If I have 3 tens and 100 over here. So you sort of get that idea. I can break things up and put them back together again. So those are just a few. There's also I'll just kind of explain Brainingcamp Live. What Brainingcamp Live allows you to do is to actually assign an activity so that your whole class can see it. So if they're on a device, they would all see what I'm seeing right here. And I could then ask them a question. So I could go down here and say, okay, everybody, let's build the number 165 this time. And so they would then have the opportunity to build that number, and I would be able to see everybody's screen. And not only would I be able to see everybody's screen, I would be able to capture that. So I would be able to get a printout of everybody's thinking. And so what that does is it enables me, we're always talking about not just having products, but making sure that we can capture observations and conversations as well. And so this is a beautiful way to capture that thinking in the moment. A nice feature of Brainingcamp. Just a couple of other little bits to show you is there are these wonderful tutorials, because you might be thinking, well, that seems complicated and I'm not sure that I would be able to, take the time to do it. There's super tutorials available that are very short. I'll just skip through it so you get the idea.
The text tool can be used to create word problems for the bar models. This is an example of a part-whole question.
So you get the idea. I'm going to get some really good math ideas, but also get ideas in terms of how to use each of those tools. And then the last thing that I'll show you, and I just need to move this out of the way, is I come back to my regular MathUP student page before I jump into the Brainingcamp, before I open the Brainingcamp tools, is I also have over here a whole bunch of lessons that are built for Brainingcamp. So if I'm also thinking I'm not really sure how to use that tool, or I'm not sure how I would put that into a lesson, these lessons are also available to you so that you can use the manipulatives thoughtfully in your class. So again, if you're interested in more information, you can actually even just Google Brainingcamp Live, but we would also be happy to explain that to you. It really works better when we're able to like all log on together with an email address and like work together as a class. But this should give you just a little hint and enough to get you thinking about those Brainingcamp tools. So I am going to stop there, and I will also stop my share, and then we will just open it up to questions. And I see there are some questions in the chat, so we'll pay attention to those too. Any questions for us? Okay, I'm just opening up this chat. Okay, it says, I'm curious with that beautiful lesson, are there those same rods that we can use with the students attached with the activity? Oh, Mary, okay, these have all been answered.
There was one I didn't answer. Oh, but it was answered. Okay.
Okay, great. I like the joke about hockey. Haha. Yeah, Canadians like hockey just a bit. Okay, are there any other wonderings for us today? Okay, terrific. Well, I will just pop my email address in the bottom here, and if you do have any questions, or you or perhaps your principal or someone would like a little bit more information, we're happy to put you in touch with the right people to do so. You can start with me, and I'll help you find the people you need to speak to. You have a great opportunity. You have Marian Small available to you right now. If there are any general math questions you might have, or even anything you're wondering about MathUP, I know Marian would be delighted to chat. And if not, we all know you are busy people, and we are in that home stretch towards the end. It's just starting to get warm outside, and you got just those few precious weeks ahead. So we wish you all the best as we head into what my old principal used to call silly season. So we hope it all goes well, and we will definitely stick around for a few minutes if there's any other questions. But otherwise, we wish you all the best, and thank you so much for joining us tonight.